Thermocline. Layers of hidden warmth in oceans.
The thermocline is a distinct layer within a body of water, where temperature changes rapidly with depth. In oceans and lakes, the surface layer is warmed by sunlight, while deeper water remains cold and dense. Between these layers lies the thermocline, which acts as a barrier to vertical mixing. As a result, heat exchange between upper and lower waters is limited. Scientists measure this temperature gradient to understand seasonal mixing and marine ecosystems. For example, in tropical seas, the thermocline can remain stable for months. However, in polar regions, it weakens or disappears during winter, when surface cooling and wind-driven mixing reduce temperature differences. Moreover, the depth of this layer varies, depending on geographical location and weather conditions. Therefore, studying thermoclines is crucial for predicting climate behavior and ocean circulation. In addition, they influence oxygen distribution and nutrient movement. Thus, both biological productivity and global climate patterns rely heavily on this thermal structure. The following story illustrates these ideas. On a research vessel in the Pacific, a young oceanographer named Lila lowered sensors to different depths. The readings revealed a sharp drop in temperature between 200 and 500 meters. Curious, she released a bright tracer dye above this layer. Hours later, the dye remained floating near the same depth, trapped by the thermocline. When a storm passed, she noticed the layer shifted upward, proving how wind and mixing could alter its position. Her findings helped map the complex thermal boundaries that shape marine life habitats. In summary, the thermocline defines a vital temperature barrier that shapes life and energy flow in water. It connects local weather patterns to the global climate balance.